Hey folks, okay, I want to give a rundown on sort of what I'm expecting from the first week of the first lab this time around. So there's a bunch of different things that we're going to introduce in this and kind of get us back into the general swing of programming. So from the course webpage, if you follow the lab resources, a bunch of information, blah, 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 blah. Somewhere down here there's a link for lab exercise 1, and that will have the most of the gory details to get us set up and running. It'll introduce the lab a little bit, talk about the steps that we're going to be going through. I'm going to walk through a bunch of those in this video and kind of introduce what I'm expecting from you for the lab. And then basically I'll assume that you're kind of doing some work on it for the next week or so. You've got roughly 2 weeks for the lab. And then in the second week's lab video, I'll be going through and talking more about some of the programming issues that I'm expecting you might have run into. So that's the general idea. Let me just ditch my little talking head here. So what I would like to do is to introduce a couple of things that we're going to be doing all semester. So we're going to be dividing our C++ programs into multiple files, and we're going to be compiling those together. So we're going to do the first of those today. And we're also going to be using our version control tool Git as the way to obtain your lab and the way to submit it later. So we'll walk through the steps for that as well. So this is kind of to introduce some of the new tools and techniques we'll be using, and then some, again, just a general reintroduction to programming in C++, get everybody back up to speed on things. And for this one, it's going to be a lot of basic use of functions, input and output, arrays, and structs. It's pretty much the idea. So hopefully nothing that's too horribly difficult, but everybody's going to be rusty after a month or so away from this. So it is important that for the Git instructions in particular, you go through and follow the instructions in sequence carefully and take a look at the messages that they're spitting out and see if they seem to be working correctly. If one of the Git steps doesn't work, then it doesn't make any sense to continue on to the next one without fixing the problem in the first one. So we'll walk through that process. I'm going to assume that you create a directory for CSCI 161, so mkdir CSCI 161. If you've already got one, if you took the course last year, for instance, then you might want to rename that so that you don't mix up the stuff from last year and this year. So the rename, you can use MV for move to rename it MV, the old name, and the new name you want for it. So if you've taken the course in the past, I'd suggest moving your old 161 stuff. So first off, we'll get into the sequence for using Git to get the repositories. So one of the things is, essentially what happens is the instructor posts the lab material on a central server someplace using Git. You're going to be creating space for yourself on that server that's going to contain ultimately the solution that the instructor is going to mark. And then you're also going to be copying or cloning your space on that central server into your own account on Otter or the Cubs or the Pups, so that you can work on it locally and then ultimately push the result back to the central server so that the instructor can get a chance to mark it. So we're going to walk through the steps for doing that. The first thing is just to check and see if the instructor has actually posted it yet. So this command, ssh -x, the -x is just to turn off some X forwarding error messages that you might get otherwise. CSCI is the server that we've got our Git stuff on, and then the command that we want it to run. So let's take a quick look at what it looks like when we do that. Yours isn't going to look quite like this. The faculty sort of test accounts here are just a little bit different. But you type in the command, run it, and it's going to give you a list of all the different Git repositories that you have access to. So again, your list is going to look a little bit different. But what you're looking for is this one. If the CSCI 161, so that -03, 05, 06 is our sections. So this is the kind of identifier for our clunk of 161 sections. And then lab1 is the lab that we're interested in. So if that exists, then you can go ahead and start proceeding with the rest of the process to go through and create it. So it has been created. There are going to be times when I might not manage to get the lab repository created until just the day of even the lab itself. So if you haven't heard from me ahead of time, do make sure that you check before you start trying the rest of this process to grab a lab. But having done this and said, hey, great, the repository's up, I can go through and try and grab a copy of it, then we'll get into the steps for actually doing that. All right, so the first step is to go through and take what the instructor has posted and create your own copy of that on that other server. So the command is a rather lengthy one, but we do want to make sure that we get it all correct. So it's this SSH to send a command to the other server, the CSCI is that other server, fork is the command to create a duplicate, and then what we're doing is creating a duplicate of that repository that we were just taking a look at. So this CSCI 161 blah 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 03, 05, 06 lab1. So that's the one the instructor created. And we want to create a copy of it in our own space. So it's the same name up front, the 161, 03, 05, 06. The $user will automatically plunk in your username there. So you can just use $user in all caps as part of your command here, and then the specific lab that we're trying to make a copy of. So the first one is the instructor one. The second one has got essentially your name in the middle of it. So let's give that a try. So we'll do our SSH-X, CSCI. Let's see, so we want to fork to create a copy of this. We're creating a copy of 161, 03, 05, 06, lab1. And I want to create it for me, so it's going to be 161, 03, 05, 06, and that $user and lab1. And you can't see any of that because I'm not showing you the window. Let me just try that again. 1 second here. Oops. 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 Come on. Work with me. There we go. Okay. So, let me just... So, again, I'm going to type in this command, the SSH-X, CSCI fork, CSCI, so again, the instructor version into my space is what I'm going through and trying to create. So I type in that command, hit enter, hopefully it works, tells me it's cloning this over on the other side, it's populating the beastie, and cloning into lab1. So this is kind of what we're hoping to see. Alrighty, so that's gone through and created the space on the other side. If we try our SSH-X CSCI info now, we should actually see that in our list. So now you see that we've got a copy of it, a copy of this lab1 under our name on that server. So that's what we want to see. Looking good so far. All right, so now we've got a copy of it over on that other server. We want to get a copy over here so that we can actually work on it. So this is where, again, I'm assuming that you've created a 161 directory. We've moved into the 161 directory, and I want to create a copy of lab1 here for me to work on. So it's a git command. So git is our version control software. Clone is essentially making a copy, and we specify what we're making a copy of, and it's going to create a copy in our current directory under the same name. So on that CSCI server, I want to copy that lab1 repository that I just went through and created. So the CSCI 161 dash blah, 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 $user lab1. So we'll give that a try here. We'll do our git clone CSCI, CSCI 161, 03, 05, 06. I want it under my name, lab1. And this should hopefully go off, grab the files, and make a copy here. And so it goes through and tells you it's receiving a bunch of objects, resolving the changes, and if we do an ls, we'll see, hey, yay, it has created a lab1 directory for me. So now I'm going to pop myself in there and do an ls, and these are pretty much the files, well, depending on how you set up ls, you might not see those dot files, but these are the files that you're going to see when you run an ls now. This lab1.cpp and lab1.h are the two C++ files I've created for you, a makefile I've created for you to compile it, and then the README is just the default Git README. So at this point, you've actually got the contents for the lab, and we'll be able to start working on these beasts. So, and I didn't show you any of that. Again, man, I'm on a roll here today. So, let me back up. So that git clone command that I typed in was that beastie there. So git clone CSCI clone CSCI 161 blah blah blah, the $user lab1 saying go off, make the copy for me. And this was the output it produced while it ran and while it went off and grabbed all those files for me. So at that point I did my ls, it showed me that I had a lab1. I went into the lab1, did an ls, and it showed me that I've got those lab files that we were hoping to see. And now we can actually go ahead and try working on this stuff. Take two. All right. So what we're going to try first off, again, they're basically just partially completed files that are in there right now. So what we'll try doing is compiling them, just see if it compiles okay, and we'll try a submit of the changes we've made, just to make sure that we can actually submit this stuff. You can submit as often as you like. It basically just sends your most recent copy across. So that way the instructor's always got the most recent version you've submitted. So we're just going to give this a try. And the idea is to compile the program. We can just use make, and this will go through and compile the .h and .cpp files together to create a lab1 executable that I think I've called lab1x. And so right now, since the files are only partially completed, you're going to get a lot of compilation warnings, but it's going through and doing this process of, it tries to compile the lab1.cpp and creates a lab1.o file, and then it compiles the lab1.o into our lab1 executable, and if we do an ls, what we'll see is it's created this lab1.o file that's just an object file. It's just got the direct machine code translation of the material that's in lab1.cpp, but it's not actually fully executable yet. The executable version is in that lab1x from that second command. So we can try running it, and I don't think it does anything very interesting yet. And yeah, welcome to Lab1, a glorified hello world. But we've given this a try. The makefile seems to work. It compiles okay. Contents of the file must be reasonably okay, other than all these warnings that we're getting. And so what I'm going to do is prepare things to submit my lab. Again, this is just to test if we can actually submit okay. So what we do is we specify any of the files that might have changes that we want to incorporate. So this is done through a git add command. This is basically saying, look at the current state of the file and remember what it is for the next time I do a commit and a push, which is going to be the process we go through. So I'm going to say add any changes I've made in lab1.cpp. I haven't actually made any, but. And I'm going to say add any changes I've made in my lab1.h. And I don't know, maybe I'll say add any changes I've made in my lab1x. Right? Those are the three things that we're really interested in: the header file, the .cpp file, and the executable itself. and I'll do a git commit. And this is basically creating a snapshot of my repository, a snapshot of these changes that I've gone through to record. And so I'm going to say my first try at submission. So you can use git commit to create the snapshot. This -m allows us to specify just a little message to ourselves or to whoever's looking at this, saying, okay, this is what this snapshot represents. So creating a little snapshot here for my first try at a submission. And it goes through and makes a note of what changes I've recorded here. And to send those back to the central server where the instructor can mark them, I use a push. So we used clone to copy stuff from the server to here. I'm going to use a push to send my changes back. And it takes a moment, and it goes through and ultimately, it checks to make sure that we're within the deadline, and gives me a name for this little snapshot that or a number for this snapshot I just took. Tells me that it's pushing from the master here to the master over on the central server. Everything looks more or less okay. So this has actually gone through and taken those changes that I took a snapshot of and sent them off to the instructor where the instructor can mark them. And again, I can do this as often as I like. If I decide I'm going to make some changes to my .cpp file, then I make the changes, do my git add, do my git commit, and do a push, and it'll send the updated versions across. And when I go through and mark these things, I'm just going to look at whatever the latest submission was. So you can do this as often as you like. There's no real penalty to pushing these more frequently. So that's what things look like just in terms of the Git, the SSH fork, the Git clone, the adds, commits, and pushes. So that fork and clone you just do once. The adds and commits you do every time you want to do a push to send results back. That's pretty much the idea. And again, we'll recap that in the lectures as well. And there are links off of the lecture resources for videos to kind of recap that process and go through and describe it in a bit more detail. But that's essentially the cycle. So again, we talk about this a little bit in the lab notes here. And finally, we can get on to maybe some actual programming for this. So the way I've got things set up is the declarations for our functions and for our data types and for our constants are in a header file, lab1.h. And then the actual implementations, the real code for the main routine and all the functions are in the lab1.cpp. And this is the breakdown that we'll use throughout the term. We'll use header files for declarations, definitions. We'll use the .cpp files for the full implementations of main routines or functions or things along those lines. So that's the way the breakdown is going to go. The makefile has been set up to compile it all and create the final executable. What I'm going to specify, we'll get a little bit more flexible in future labs, but for this first lab, I've set up the .h file correctly. I've given specific definitions for all of the functions and comments describing what I want every function to do. So you have to stick with those. You're not allowed to alter the lab1.h. What's going to happen when I actually test your programs is I'm going to use my original lab1.h. So if you changed your lab1.h to make your program compile easier, because you didn't follow the specs in your lab1.cpp, it's not going to compile on my side and it's not going to get very good marks. So don't change the lab1.h. Your lab1.cpp is going to have, again, the main routine and the bodies of all these different functions that I'm specifying. So you're fairly restricted in terms of the behavior of the main routine and the functions for this lab. Again, we'll get more flexible later on. So the way it's going to work is this particular program is getting information just about a whole bunch of circles from the user. where it's got, the coordinates for the center of a circle and the radius of a circle. And it's going to say something like, how many circles do you want to do? The user might say 5 or 10 or 12 or 3 or something like that. Then for each circle, the program's going to go through, get the coordinates for it, get the radius of it, and then it's going to go off and compute, I think, the circumference and the area for each and display that for each of those circles. So what's going to happen in terms of the implementation is we're going to be using a struct to contain the information about a circle, right? The x and y coordinates of the center and the radius of it, and fields for the area once we compute it, and the circumference once we compute it. So we're going to have these structs. Our main routine is going to create an array to hold the structs for all of the different circles that we actually use. And it's going to be calling a bunch of functions to, ask the user how many circles they want to do, functions to get the information about each of the different circles, functions to do the computations for area and circumference, and functions to go through and print all the results out in the end, pretty much. So I've gone through and specified what each of those functions is supposed to look like. And again, there are specs for what the main routine is supposed to do, specs for what each different function is supposed to do. As I mentioned in the lecture, I do want you to go through and review the code standards for the course. There are a fair number of them. Your code must compile cleanly, no warnings. If you do wind up using code from anything that I haven't explicitly given you for the lab, then you do need to make sure you give a proper attribution for that. You have to do proper error checking. The output has to be clear and informative. If it tells me if it's supposed to be printing out the area and circumference of a circle or some such thing, then don't just print the numbers. Print information that makes it clear to the user what's going on. Your code should be reasonably well commented. I've got a few notes on that. The layout, again, what kind of indentation, the use of white space, the use of properly declared identifiers and clear variable names and constant names and that kind of thing, the use of constants and not hard-coded literal values. So make sure you go through all of this. One of the things I know in some sections of 160 you are allowed to use global variables. That is not the case this term. I will penalize you heavily for using global variables, so read the standards on that. We're not doing file I/O yet, but there are some standards in there for the use of that. We'll have standards for classes and methods, good design practices, so good top-down design. So again, go through all of this and make sure you read the different specs, the use of header files, what's supposed to be in the header files, what's supposed to be in the .cpp files, namespaces when we get to those, makefile standards for when you're modifying your own makefiles, documentation. Actually, that's one that I'll mention now specifically. For your lab, I do want you to include a README that has a short note on how to run your implementation of the program. This is particularly important if you haven't exactly followed the specs. If you've changed something, again, you're not supposed to, and you're going to be penalized for it, but you're going to be penalized more if you have incorrect behavior and don't tell me about it. So if there are any known bugs in your program, note those in your README, right? So anything that you see in your program that you know doesn't work, stick a note in the README. I'm going to penalize you more heavily for bugs that you don't know about than for bugs that you do know about. So if you warn me that it doesn't work properly in this circumstance, then I know that at least you've recognized that, and at least you found that maybe you didn't get a chance to fix it, but you know it, you're aware of it. If you don't even know about the bugs in your program, that's going to get penalized more heavily. So do make sure you create your README. So a whole slew of different standards that I do want you to go through. And for the most part, I've tried to explain the whys in the standards as they go through, but do have a look at them. All right. Again, anytime you go through and start modifying your program, remember to do your adds and commits. Remember to do your push at the very end. There are some sample runs here for what the behavior of the program should probably look like. And here, just to make the sample run easier to read, I've stuck the stuff that the user's typing in bold and italics, but you're obviously not going to be doing that in your actual implementation. But again, it's going through, asking the user how many circles they want to work with. For each circle, it's going to get the user to enter a name for the circle, a radius, the x and the y coordinates, right? So it's going to get the data on all of the circles, and then once it's got the data for all of them, it's going to be going through and printing out for each circle its name, its coordinates, its radius, its area, and its circumference, right? So it's going to be going through and printing out all that information for each of the different circles. And again, there's going to be a bunch of error checking requirements in here. So as you're reading through the specs, you can have a look back and forth at the sample runs to see the kinds of things that I'm looking for. And again, remember to do your adds, commits, and a push at the end so that the changes that you've made actually make it back to me for marking. Alrighty. So in terms of the contents of the files, again, I'll just take a quick look at it here and give you a bit of a look at what's going on. So in that lab1 header file, the .h file, it's going to go through and do some includes for things that we're going to be using. We'll use strings for the circle names. It's going to declare a constant that we're going to use for pi. It's got the definition of the struct for a circle, right? So it's got a string field for the name, and it's using doubles for x, y, and the radius, and doubles for the area and circumference that we're going to compute. And then again, it goes through the list of functions, what each function is supposed to do, and then the profile for the function, the return type, the name, the parameter list. So again, you're not allowed to change this. You actually have to implement these functions using these names and these parameters. Right? So there's a fair slew of them. Most of them are fairly easy to implement. And again, as you're going through, do this incrementally, right? Get basic versions for the functions implemented and debugged and working, and then start adding the different error checking and any kind of repetition and that sort of thing that needs to take place. But have a go through. And then if you take a look in the lab1.cpp file, you'll see that it includes our IO stream and IO manip for the output. And it includes this lab1.h that we've just gone through so that it can grab the definitions from that header file. And in this case, I've gone through and said, okay, well, out of that standard namespace, I'm going to be using cin, carr, cout, endl, set precision, set ios flags, and ios, right? So a few of the things that I'm going to be using. I'm avoiding the use of using namespace standard, and I'm just specifying exactly which things I'm going to use from in there. So in the initial version, again, it's got a main routine that's basically just a kind of a hello world. You're going to be replacing that with the actual code for the main. And then for each of the functions, again, we've got the profile for the function and just a skeleton version for now that you're going to replace with the real code for that function. All right, so at the moment, it's set up with just sort of dummy versions of each of the different functions, right? And you're going to be completing each of them. All right. I will leave it there for this one, right? So for this week, you can just get the hang of using Git, using the makefile. If you want to take a look at the contents of the makefile, feel free. Again, it's got the instructions for, it builds the lab1 executable out of the lab1.o file using this command. It builds the lab1.o file itself based on lab1.cpp and lab1.h using this command. And if you ever want to get rid of the .o files and the executable and sort of recompile cleanly, you can use a make clean. So I'll just, show you that. So if we do our ls, we've got the .o file and the executable sitting around in there. If I do a make clean, it'll get rid of those, and I recompile, and it recompiles, and again, we've still got the warnings because we haven't fixed any of those. If you haven't changed anything and you do a make again, it basically goes through and says, you haven't edited anything, it doesn't need to recompile. So it's smart enough to recognize when it needs to recompile files and when it doesn't. but we'll talk about that more in some of the lectures on makefiles. All right, I will leave it there for now. Have fun with this stuff, and in the second week's lab, we'll go through and talk in more detail about the different coding aspects for lab 2. Alrighty.